sort of latest numbers of what could actually be got out of the ground, rather than you'll hear a load of huge numbers bandied around which are gas in place, estimates of what the gas is under there, but with these unconventional technologies you can only ever get a few percent of it out. So, you know, the actual extractable gas, you know, is much lower. And the shale gas, at the moment, they're talking about maybe a year and a half of UK consumption being extractable, which would be, you know, you would need 5,000 wells even to get that small amount of gas out. The coal bed methane, you know, 2.5 years is what the latest estimate, but coal bed methane wells produce even less gas per well than shale gas wells. So you'd be looking at 20,000 wells to get that out. And then this is all very vague numbers, but again, it's like, you know, you want even moderate amounts of gas. You're talking about tens of thousands of wells to get it out. So this whole industry is like, you know, it's not just the pads. You know, there's all sorts of ancillary infrastructure. You've got to transport all sorts of equipment out to these pads when you construct them and then drill them. You've got to take, you know, things in and out, you know, water to the pads potentially for your fracking, then like gas and waste have to come out either via pipelines or via tankers. So there's a whole mess of different impacts, and I can only have time to talk about a few really, but obviously this is one that a lot of people have heard of, you know, this problem with methane infiltrating into groundwater, and if you have a water supply that comes from a borehole rather than from the mains, then, you know, there have been quite a lot of cases both in the US and Australia where people have actually been able to set their tap water on fire due to this, which is obviously, you know, quite photogenic if you want to bring a journalist around and show them this and take a picture like this, but it's quite worrying for the people actually involved who have to worry about this gas building up in their houses. And there's a lot of scientific data now coming up to back up all these anecdotal stories. So this is a study from the Duke University in Pennsylvania showing that water wells within a kilometre of a shale gas well have a much higher probability of having large levels of methane in the water. Obviously, if the methane can be making this journey, you've got to worry about what other things could make the same journey. And this is just some data from a draft Environmental Protection Agency report from a place called Pavilion in Wyoming, which is right in the middle of a gas field. And all sorts of, you won't be able to read this, but this is all sorts of nasty chemicals, things like benzene, toluene and ethylene glycol and things like that, and some really high levels of those chemicals in these water wells. There's also a whole issue just around the number of these wells that have to be drilled and the sort of legacy that leaves for the future. Because the industry's own data shows that basically all these wells are going to leak eventually. You know, so this is from a massive oil services company called Schlumberger. They're basically Halliburton's largest competitor. This is for shale, for actually just ordinary conventional gas wells in the southern United States. And if you look at this, so, you know, this is for, you know, basically as soon as they've been drilled, about 6% of them are leaking in some way or other, and then that just steadily increases with time, and within about 15 years, half of them have some sort of integrity issue. And that's not actually surprising if you think about it. You think what one of these wells actually is that they basically sink a load of steel casing and cement into the ground and then just leave it there forever. So, you know, steel rusts, you know, cement crumbles, you know, the casings on these wells will, you know, degrade over time, and the actual evidence is they degrade really quite quickly, and, you know, leaks start popping up almost immediately in some cases. Air pollution is another big issue, probably an underappreciated one. Probably most of the people who are reporting health effects from in these areas at the moment is more likely to be air pollution than water pollution initially, because air pollution comes in straight away. The rigs turn up, all this other equipment turns up, they start drilling, and you've got air pollution immediately, whereas this water pollution is a more slow burning issue that slowly comes in over years as these wells start to leak. So it's caused by a whole variety of things: the flaring of the gas, all the emissions from all these massive diesel engines that run the rigs, and the frac pumps, leaking pipework and tanks, all sorts of things. But it does seem to really be quite a sizable issue in some of the sort of high desert like areas like Colorado and Utah and Wyoming, where prior to this industry turning up, they had some of the most pristine air in the United States. Then they come in, drill thousands of these wells all over the place, and suddenly these areas are having ozone levels spiking to higher than the centre of Los Angeles, and all sorts of other volatile hydrocarbons and things like that in the blowing wherever the wind will take them, basically. In terms of health effects, up until recently there hasn't been a lot of targeted studies of this, so it was only where things got picked up by chance. So this is just one case for the Centers for Disease Control. We're doing a big cancer survey across the whole US, and it happened to pop out of their data that these 6 counties in Texas that sit right on top of the Barnett Shale, where shale gas drilling first got going in the States, and about 15,000 wells have been drilled in that small area so far. So in those 6 counties, the breast cancer rate was shooting up while it was slowly declining in most of the rest of the US. Since then, there have been, mainly in the last year or so, there have been slowly some people taking interest in doing targeted health studies to find out how the health of local residents is being affected, and some quite worrying correlations are popping out. Things like low birth weight for infants, where correlated with the distance their mother lives from a shale gas well. All sorts of issues around air pollution and asthma in places like Texas. Blood pressure, high blood pressure associated with the exposure to shale gas flaring, all sorts of things like that, and not just in the US, also in Australia as well. Transport is also a really big issue. Basically, if you think about it, this is a really dispersed industry. You're talking about thousands of pads spread out over a very large area, and you've got to get all this equipment and material out to all these pads, and then bring stuff back again afterwards. And you're looking at maybe 2,000 to 4,000 truck movements to frack one well, and then you've got maybe 8 or 10 wells on a pad, and then maybe hundreds of thousands of wells in a particular area. So that adds up to massive amounts of truck movements, often down quite rural roads, and the evidence is stacking up that it's like really quite basically carnage on the roads in a lot of these drilling areas. So this is just a study from Pennsylvania showing that as the drilling boom ramped up, coming through 2007, 2008, 2009, sort of the road accidents were spiking massively in the counties where the drilling was happening, while continuing to decline in the counties where there wasn't any drilling. Earthquakes are another issue. There's some subtleties to it. Quadrilla caused those earthquakes in Lancashire when they cracked the first shale gas well in the UK. They're quite small earthquakes, and the main issue with them was they actually destroyed their own well. The well casing underground was like squashed from circular to oval due to the movement of the rock, and they're now plugging and abandoning that well, but you've got to worry about it leaking even faster than any of the other ones were due to the damage that's been done to it. But there's a potentially much bigger problem that's not with the fracking itself, but with the disposal of the frack waste. Because, you know, certainly in the US, the two main methods we've seen for how they try and get rid of these, like, you know, basically millions of gallons per well, and then you're talking about thousands of wells, you're up to, like, you know, billions of gallons of waste that's contaminated with all sorts of things, including, you know, radioactive materials like radium, and how do they get rid of it? So one method has been to, like, you know, just send it to municipal sewage treatment plants and, like, sort of mix it in with the sewage stream, and it ends up being diluted with sewage and then just going into rivers and things like that. But the other way of getting rid of this waste has been to re-inject it underground, either into old oil and gas wells or into wells they've specifically drilled in order to put this waste down there. And this is where we've been seeing some really quite big earthquakes. So the largest so far has been a magnitude 5.7 in Prague, Oklahoma. And, you know, 5.7 isn't like, you know, a sort of magnitude 8 that will kill thousands of people, but it did $100 million of property damage, tripped the safety systems on 2 nuclear power stations, causing them to automatically shut down. So it's like not an insignificant earthquake, even though it didn't actually kill anybody. But if you look at the statistics for earthquakes just in Oklahoma, up until 2008, you know, maybe they got 1 or 2 or 0 earthquakes a year. Then, since this whole boom in light fracking has taken off, you know, the large earthquakes greater than magnitude 3 have just been shooting up. You know, last year there were over 100 of them. This year, just until June 17th, there were over 200 earthquakes greater than magnitude 3 in Oklahoma. You know, it's just like it's just shooting up, and, like, you know, people there are getting really worried about it. Global warming is obviously the sort of elephant in the living room with all of this. You know, these unconventional fossil fuels were stuff we weren't expecting to burn up until now, and now they're being thrown on the table to be burned in addition to all our conventional reserves of fossil fuels. And pretty much we could only afford to burn about between a fifth and a quarter of conventional fossil fuel reserves and stay below a temperature rise of 2 degrees C. And given the sort of massive increases we're seeing in extreme weather events, things like droughts, floods, you know, major storms, etc., you know, almost tripled over the past 30 years due to global warming, and that's just the beginning, and fracking could make that far, far worse. So I'll just talk a bit about, like, what people can, you know, potentially do about this. You know, as we've heard, you know, if you look over, you know, the sort of whole year